All right, here we go. Go deeper question. This go deeper question is meant to get you ready for FRQs, those pesky free response questions that we're going to see on May 14th, which is nicely 2 months after Pi Day. So let's focus on A. After reading the initial prompt, the function f has derivative of all orders for all real numbers x, and I'm given f of 2 is this, f prime of 2 is this, f double prime of 2 is this, and f triple 2 is this. All right, there's some givens. I don't know what to do with those yet because I haven't read the question. Part A, write the third degree Taylor polynomial f about x equals 2 and use it to approximate f of 1.5. That was a mouthful. Write the third degree Taylor polynomial for f about x equals 2 and use it to approximate f of 1.5. So there's really two things going on here. I need to do this, and then I need to do this. So let's start with this, and then do this part. I see it says the third degree Taylor polynomial for f about x equals 3. Because it says third degree, I know my highest degree term is going to be x to the third, which means I will need the third derivative. That's nice. They've included that. Great. And it says about x equals 2. So the Taylor polynomial for f about x equals 2, that's really telling me that the c value is 2. So that's important to note. They usually won't say here's c. That's what it is. You need to pick up on the context that it's about that x value. So let's go from here. I know from my reference sheet or from my notes that the general term for a Taylor polynomial is the nth derivative at c over n factorial times x minus c to the n. If I use this, I'm going to get any Taylor polynomial term I want. So the first term, n would be equal to 0. So that would be, if n is 0 here, that's just the function. 0 factorial we know is 0. X minus c to the 0, that's just 1. So it's really just going to be whatever the function is. That is negative 3. Plus, and then I know that this would be the first derivative at c over 1 factorial times x minus c to the 1. So first derivative, that is 5, over 1 factorial times x minus c was 2 raised to the 1. I have my first degree Taylor polynomial, but we need to get to the third degree, so we keep going. Plus, I'm going to use my n equals 2, so second derivative, that's 3, over n factorial, that is 2 factorial. Notice that it just builds off of the previous one. And then x minus 2, not to the 1, but to the 2. I have my second degree Taylor polynomial. I keep going. I get plus, then I need the third derivative. It's giving me that. It's negative 8 over 3 factorial times x minus 2 to the 3. Have I answered this question? Third degree Taylor polynomial. Great. I'm going to label that p of x, p sub 3 of x, just so I know what I'm referring to. Did I do this? I did. Great. Now I got to do this part though. Use it to approximate f of 1.5. So what I can do is if I want to approximate f, which I don't really know what that function is, I can plug in 1.5 for these x values to get an idea of what f of 1.5 would be. So f of 1.5 is approximately p sub 3 of 1.5. And then I'm going to treat this 1.5 as 3 halves. It's going to be nice to work with 3 halves instead. So that would equal negative 3 plus 5. 3 halves minus 2, that's negative 1 over 2. Plus, this is 3 over 2. And this would be negative 1 half squared minus 8 over 6 times negative 1 half cubed. I'm going to go term by term, simplify this till I get my answer. Negative 3 minus 5 over 2. Plus, this would be 3 over 2 squared is 8. Negative is going to cancel, and I get, 2 squared is 4 times 8 times 2 gives me 8 there. Then this last part, I get 2 to the third. That's going to be a negative 8 in the denominator. Times 6, that's negative 48. But I also have a negative here, so this will be plus 8 over 48. Let's do some simplifying to make this a little bit easier. That would be negative 3 minus 5 over 2 plus 3 over 8. And then I know 8 over 48, that is positive 8 over 48, that's 1 over 6. So I keep going, need to find a common denominator. I'm going to use the number 24 So this would equal 3 times 24, that is 72. So negative 72 over 24 minus times 12 minus 60 over 24 plus 3 over 3, that'd be 9 over 24 plus 4 over 4, that'd be 4 over 24. I can combine all these. I get negative 32 plus 9 would be negative 121 plus 4 would be negative 117 all over 24. That answers that second part there. All right. If you see an error, post it on Google Classroom. I'll give you extra credit if there's an error in there. All right, part B. The fourth derivative of f satisfies the inequality. Okay, interesting. For all x in the closed interval 1.5 to 2. Use the Lagrange error bound on the approximation of f of 1.5 found in part A to explain why 5 cannot equal negative 5. Whoa, a lot of things going on here. But I know if I read Lagrange error bound, I'm going to have something f of some value x minus p sub 3 of x, absolute value, is less than or equal to the max of the fourth derivative at some value z over 4 factorial times x minus c to that same power 4. So let's see what we can do with this, and then we'll see if we can get to something like this. So here we go. I know f of x I can't find, but I'm approximating f of 1.5 minus, I have my answer over here, which would be negative 117 over 24 in the absolute value bars, less than or equal to, what is the maximum value of the fourth derivative between 1.5 and 2? Well, conveniently, they told me that it satisfies this inequality, so it's always less than or equal to 3, so I'm going to replace that with 3. Over 4 factorial, that's 4 times 3 times 2, which is 24 times 1.5, or yeah, 1.5 minus 2, which are my numbers from above. That would be negative 1/2 to the fourth. So let's see what we can do to this side to simplify this side. That would be 3 over 24. 2 to the fourth, that's 2 times 2, that's 4 times 2 is 8 times 2 is 16, so I get 1 over 16, like this. Let's see if I can simplify that further. That would be, this is 1 over 8, 1 over 8 times 1 over 16. 8 times 16, that's 80 times 10. 8 times 10, which is 80, plus 8 times 6, which is 48, so that equals 1 over 128. Great. So I have the inequality, f of 1.5 minus, or plus in this case, 117 over 24, absolute value, is less than or equal to 1 over 128. All right, let's keep going. So using my inequality here, I could break this up into a compound inequality that looks like this. Less than or equal to 1 over 128. 1 over 128. And then I want to get a range of values for f of 1.5 to fall in between. So that would be f of 1.5 less than or equal to negative 117 over 24 plus 1 over 128. And then this would be negative 117 over 24 minus 28. There we go. Got to find my calculator real quick, so I'll be right back. Make sure you have this. And then what we're hopefully, needed this sign here. So what we're hopefully going to see is that this range of values does not include negative 5, and that would be helpful. So got to find my calculator. Be right back.